Welcome everyone to another Observability Clinic. Forecasting with Dynatrace is the topic of today. It's forecasting on business, app, and infrastructure data with Dynatrace Davis Forecasting. We started a complete new series, really focusing on use cases that are really meant for data scientists, data analysts. And I'm not a data scientist, I'm not a data analyst, I don't want to pretend to be one, but I have two people with me, Linda and Bernhard, who can tell us more about what's new in Dynatrace around forecasting. Linda, Bernhard, servus, grüß euch.
Hi.
Hi. Hey, thank you so much for doing this. You are, as I said, much more equipped to talk about these topics. Maybe a quick round of introduction, because I think it's the first time both of you are on my clinics. Linda, just a quick word to yourself.
Yeah, hi. So I work in the data science team together with Bernie, and we are working very hard on these forecasting algorithms.
Very cool. Bernhard?
Yeah, hi, I'm a mathematician turned software engineer. No, and since 3 years here in the data science team, Dynatrace, and forecasting is one of our main topics, among others, but let's focus on that today.
Perfect. Then let's jump right into it. What have you guys prepared for us?
Thanks. So we have prepared some first use cases on how forecasting can help you to drive your business decisions.
Mm-hmm.
Then we will continue with some theory about our forecasting algorithms, and we will conclude the session with a hands-on demo to show you how forecasting is incorporated in the new platform.
Perfect.
So let's head right into the use cases. And here I want to shortly talk about reactive versus predictive maintenance. So when talking about the infrastructure companies have to monitor, you usually think of business critical resources, like, for example, disks. And the old way, or the common way to monitor those disks is by collecting data about your resources, for example, how full your disks are. And then you can create alerts or warnings you receive when a certain threshold is exceeded. For example, you will be alerted when disks reach a capacity of 95%, for example. But looking at the large scale and highly dynamic infrastructures we have nowadays with our cloud-based solutions, this can become quite overwhelming because you get many alerts for lots of different resources, and you first have to find out which resources are affected, which teams have to take care of this, and then you have to take action too, so these alerts then get resolved. And this can happen at any time because these alerts do not really take into account what your business hours are.
Mm-hmm.
So on the other hand, there's predictive resource management. And predictive resource management means that you create schedules for your resources to be monitored, for example. So you first say you want to create a scheduled forecast of your disk capacity or disk demand in the next week.
Mm-hmm.
And based on this result of the forecast, you can then take action. These results can then include, for example, the people who are responsible for the resources, and they are informed before any critical incidents happen. So this enables you to create a more optimized and also employee-friendly way of maintaining your infrastructure.
Mm-hmm.
So to sum up, reactive maintenance means that you create alerts based for unseen events, for example. This is very suitable still, but
Mm-hmm.
it also means that they are very unforeseen, or there are lots of So this also means there are many alerts which are outside of your business hours, especially for our large scale cloud systems.
Mm-hmm.
And this can also lead to very resource intensive and not optimal actions you might have to take care of. Predictive maintenance, on the other hand, helps you to make preemptive decisions and take actions based on an optimal routine, for example. And since this is directly integrated into Dynatrace, you can also leverage the new capabilities of Grail and Davis.
I think, Linda, first of all, thank you so much for these two things. I just want to recap quickly, because I've seen this so many times, and I'm on a tour here, meeting customers and users of Dynatrace, and the whole discussion around how many alerts do I need to specify, and why am I then bombarded with so many alerts and what to do with it. That's exactly what many are still doing, and that's what people have in their head with the reactive. The predictive really is reducing the noise, so actually never let it come to a problem by using mathematical models. Hopefully I can pronounce this correctly, and just predict when it is time to actually change a system, so that you actually never get into the situation that you actually get an alert. And I think that's the really nice thing, and this is a huge mind shift, especially, as you said, in environments that are hugely dynamic, that have to be run 24/7, and nobody wants to get woken up in the middle of the night on a weekend to then react to an alert if you could have prevented the whole thing.
Yeah, that's true, and this is where we hope to help to shift the mindset a little. So now we will continue with the theory about probabilistic forecasting. So Bernie?
Yeah, thanks. Here I have this little bit of an hyperbole as a subtitle, why point forecasts lie to you. This is with it's not to be taken literally. They do not lie to you, but they also do withhold information from you. So if we look at these three forecasts on the right-hand side, right? 3 different time series, different variability, and still very similar forecasts. So if you think about something like a simple linear regression, we always think of data and then a straight line extending somewhere. But as we can see here already, we lose some information about how much the data, about the uncertainty about the data, right? We can be very sure of our prediction in the first time series, but on the third time series, there is a little bit of gray area where we say, yeah, the general trend is in this direction, but we are not totally sure where the time series will land on. And if, for example, our critical value, I'm sorry, it's a little bit small here, would be 12 on the y-axis, then our forecast would make us believe that we will never reach this, right? But in truth, we'll reach it quite frequently. And this information we lose with a classical point forecast. And this is where, and please give me the next slide, these probabilistic forecasts come into play, where basically we do not only want to predict the expected value of the forecast, but the whole distribution. And then here in blue, this is not the whole distribution, but some confidence interval. For example, I think in this example, it's the 5th percentile to the 95th percentile. So we expect around 90% of our data points to lie within these confidence intervals. And this opens up a whole set of questions that we can answer now. We can have better planning, as in, for example, if we have a 10% chance of running out on this storage within the next week, maybe we already want to take action. Maybe we'll just take action after if the probability increases to 20%. But we can set this threshold and we can say, well, we never want this to happen, so we want to be more conservative in how to resize disks. This is now, these are questions that we can now answer, and this is, I think, quite nice about this.
And Bernhard, just also from my understanding and to bring some analogies, I think what you're telling me here is that it's about risk management, right? Because you can basically say, what risk am I willing to take to make a certain decision? And you can basically say how much risk, and that depends on how broad that band is. And you know what the whole thing reminded me, and this is completely independent to our area, it's about weather forecasts. if you look into, in our case, we look at ORF maybe, right? That's the Austrian news channel. And then they always have the weather at the end of the news section. And then you see like, what's the weather going, what's the temperature going to be in your city? And then obviously the further you're far away you go into the future, the broader the band. But that just visually reminded me of it. What you're saying, yeah.
Yeah, that is a very good example of weather, because forecasts about the weather are famously uncertain, right? And so telling somebody it's gonna be 12 degrees tomorrow will be most probably a lie.
Yeah, that's true. Yeah. But you can say there's a 90% chance that the temperature is between 8 and 15.
Yeah, exactly. And this is more likely to be true.
Cool. Thank you.
Yeah, so maybe let's have a look at how we produce these nice little forecasts here at Dynatrace. This is, in our case, a two-step process. First off, here we have some time series. It has a trend, it has a seasonality, it has some noise. So everything we want to be able to predict, basically. And what we do is we create some features from this time series, as we would do, for example, with a simple linear regression. For example, here we have some things like calendar features, autoregressive features, or some seasonal features. And what we do with this is not the classical L2 regression, but we plug it into a quantile regression. What does that mean? Basically, it means we are looking at a different loss function than our squared loss, basically. This is, if we want to look it up, the formula, it's the pinball or quantile loss. You can find it anywhere, including Wikipedia, very easily. And what we can now do is we can train a regression model that has as a target not the mean or the median of our target value, but a certain quantile of it. So as we can see, we can have multiple models for different quantiles. And depending on how much time you bring, you can train more or less of these quantiles. And what we do is basically we only produce a quantile, the forecast quantile for the next time step. So now so we put in our features and we gain back, hey, the next time step has this quantile. So now we would question, and how do we make longer forecasts, right? Because obviously it's nice to have the next step predicted, but this could be minute resolution and nobody will be happy to be woken up 1 minute earlier. So here we have this 4-step approach. Let's begin on the left upper side. This is what I've already told you. We have a time series and we predict for the next time step these 3 quantiles. In this picture, it's the 25th, the 50th, and the 75th quantile. The nice thing about this is that it's that we do not have any assumption about distribution. So we can look at the quantiles and then draw conclusions from there. So in the next step, on the right-hand side, on the right upper side, we now can estimate distribution from these quantiles. So we already have some information and then can create distribution from there. And obviously, if we take more different quantiles into account, we can make better prediction about this distribution. So what can we do now? Well, we can sample from this distribution. We can sample 1 point from this distribution and then rinse and repeat, basically. So the new sample point becomes a point in our time series, and now we can make a prediction about the next point in time. This is not then a complete distribution, but it's one possible path that this time series can take. And we do this a lot of times, and that we can see on the right lower side. We do this sampling of paths many times, and now we can just take, again, quantiles of these paths as our confidence interval. So if we say, well, if 90% of our paths are lower than X, then we say, well, then we assume, then we predict that a time series will, with big certainty, like 90%, be below this threshold. Is this clear maybe on this?
Yeah. It is clear. I mean, even though I'm not at all in that field, but it makes a lot of sense that you're basically looking at the data, coming up with your individual points, and then just rinse and repeat, and then go through different models on how the values can basically go forward. Yeah, no. I know I'm not doing a good enough job or a nice enough job as you is explaining it, but for a non-mathematician, I think I understand. But I know there's more slides to come, and also with the demo, I think later on it will be not only crystal clear but also visualized clearly.
Yeah. Well, and we try to visualize it already. So basically taking this one-step forecast and this sampling technique together, we can now forecast the time series from the first slide from this section. And we can see that we get very nicely this median forecast as the point prediction in the middle, but also the confidence band that is driven by the noise and the seasons and the trend. So I'm quite happy when I look at such pictures.
Me too, and knowing that this is not just some visualization in some external tool, but I believe this is all Dynatrace, which we will see.
Yes, this is straight from the notebook.
Yeah.
Yeah, and this is now a little extra, basically, as we are optimizing the pinball loss. We are looking at data that we collect from any tenants from anywhere, basically. So it might be that there is only very little data point, that there is basically no variation at all, like a straight line, or that our optimization algorithm may not converge altogether. So maybe we cannot compute a result. And for that case, we kind of want to have a fallback. And in our case, we use a simple linear regression with the prediction intervals that I think are broadly available everywhere as a formula, as a fallback if everything goes wrong, or there's so little data that training a more complicated model is not making sense.
Cool.
Yeah, and with that, I think we can hand back to Linda to show you where the magic now really happens.
Yeah, but thank you so much for the explanation. That was really helpful, and I'm pretty sure many that watch that have a background in mathematics or statistics, they're all like smiling now. Me too, even though I don't have a whole lot of background in it.
Yeah, thanks, Bernie. So now let's head right into our hands-on demo, I'd say. So for this, we've prepared a little notebook where we can show you how you can write DQL queries and also directly forecast on this data you query. So if we think back of the intro where we talked about disk metrics, here you can see a DQL query which queries the available disk space. We can say let's have a look at the last 30 days of the disk space which is available, and we want to see it per disk we have. So then we can take the correct action. So if we run this query, we get back this data. Then we can say, okay, I want to know how the data for this series, so for the blue one, might develop into the future. Then you can say filter and forecast. And now we get back a forecast of the data, and we can see how this will develop over the future, or how it might develop over the future. And this shows the forecast for the next 100 days. So we can see how this might behave. Yeah, but this does not only work for disk metrics, it also, or for capacity metrics, it also works, for example, for written bytes. So here we see some series about which shows how many bytes were written on our hosts. And then we can also say here, filter and forecast. And it's just very easy. You just click on this interaction and then you see a forecast of the data. And now you can see the prediction for a time series which has many upper spikes. And we can also depict this behavior of the time series. So this is very great to see whether a threshold, for example, the upper threshold for some written bytes is exceeded, for example.
Can I ask a quick question on this?
Sure.
So first of all, great. So that the only thing I need to do is on a chart, click on the metric, and then I can turn on that prediction. What's the minimum data set I need to have, and how far into the future do we predict? Is this something that depends on the time frame that I selected, or is this something that I can configure?
So to answer your first question, we need at least 14 data points for a linear forecast to work. And for a more complicated model, I'm currently not sure what requirements we have there. Bernie,
At the moment, we have 30 data points.
30, okay. So you said 14 for a linear and 30 if you want to have the other model. Okay, that's good.
Yes. And regarding the forecast horizon, so that's the name for the time span we want to predict ahead. This is at the moment a fixed value. So we always predict 100 steps ahead.
Okay.
And the step unit is the unit which is
the resolution on the
chart. Resolution of the data, exactly. But we are already working on ways to configure it. So you can say you want to predict only the next 7 days or 7 steps ahead. This is in the works, and we hope to get this out soon.
Cool.
Yeah. We can also not only predict or make predictions for data which has no trends. We can also, for example, as you can see with this metric of free disk space, that we can also capture downward trends and then create a forecast for this kind of data. So this perfectly showcases that we take into account the downward trend, and we also increase our prediction interval over time, since we are more uncertain the further ahead we predict. Yeah, so the disk metrics are not the only thing you can predict. You can use any metric which is available in Dynatrace and has enough data points. So here you see that we can also use it for the memory used, for example. So you just, once again, select the time series, click filter and forecast. And then in the matter of a few seconds, you get a forecast of your metrics. Yeah, and we can also capture the seasonal patterns, as you can see here. This is very cool, actually. So this is the forecast, and this is the actual data.
That's also nice. So I just see this. So basically, we automatically get with the forecast additional kind of data dimensions on the chart, and then you can visualize them individually. Yeah, that's nice. It's a short feature.
Yeah. You can only see the point forecast, for example. You can also select the regular data, and I think you can. Yeah, you can customize also the. Yeah. And you can also not only use the time series command, you can also summarize it by hand, for example, if you want to investigate log lines. And yeah, so this is what you can do in the notebooks. Do you have any questions about the notebooks?
I think you just answered the other question that I had with this one here, because I assume this is not a feature that is tied to time series. It's a feature that is tied to any type of data point we can extract through TQL queries, whether it's metrics, whether it's logs. I guess BIS events is another thing. I have a lot of conversations with people right now around business events, and then obviously traces are just the next thing to come in Grail. No, this is awesome. And so I can put this on a notebook. And folks, if you're not familiar with notebooks, there is that we already have some other videos that talk about the new analytics options we have with notebooks and dashboards. So also, if this is completely new for you, check out the other videos so you get an introduction on these new kind of visualization and analytics features in Dynatrace. Other than that, I mean, for me, the next big question is, I guess, does this also work in dashboards? And how about automating based on this data? I think these are two things that I would have as an additional question. I'm not sure if you're going to cover this, but that would be my question.
Yeah, so dashboards will also receive the forecasting feature. this is planned for the next few quarters. So this is definitely also a thing we're working on and trying to get this in there as soon as possible.
Cool.
And regarding the automations, I've also prepared a short demo.
Okay, that's good. Here we go.
So I have already created an example workflow. So this is a fixed time trigger. This means this runs every working day of the week at 8 o'clock. You can also change the rule. For example, you only want it to on the first Monday of every month, for example. And as a next step, I added the Davis Analytics task. And here we selected the generic forecast analysis.
So that's a new action. So that means there's an app.
Exactly.
That's the Davis Analyzer, and now you can use that as an action in your workflow. I mean, that's awesome. I mean, that's sweet. Yeah,
and here you can then also customize your things. So how many steps ahead you want to forecast, and what the coverage, so the confidence interval, the width of the interval, you can also configure here. And you also specify the query you want to analyze or monitor. So here we, for example, query the available disk space and set it for the last 7 days. So you can set the time frame in the query, or you can set it in the component itself or in the task itself. And after the prediction is run or was run, we check the result. For this, you can create a custom JavaScript task, and there you can then just do whatever you want with data, since you get back a result. And you can, as we do here, check if the execution is successful. And then we just check whether the threshold was exceeded. And if it was exceeded, we can then, as a final step, send an email. This is not yet implemented, this task, but this is the final step we can then do here.
Yeah. So I first of all, really cool, and I want to just mentally prepare people on how I see this work. You would mentally start in the notebooks, because in the notebooks you can analyze your data, you can figure out what are the right metrics, what type of prediction, like what type of trends do you see, and then you would take the DQL query from your notebook and then put it into workflow like you did here with the predict disk capacity, right? So notebook, explore the data, bring it over the DQL into a workflow, and then like in your case, it's an example of sending me a report every day. I know internally we've done a little bit more where we actually actively then trigger scaling of our environments based on the output of the prediction, whether it's email, whether it's Slack, or whether it's executing any external API to scale, let's say, your cloud environment. In the end, it's up to you to execute whatever type of actions.
You can also execute multiple actions in parallel, for example, after checking the prediction. So you can do many things here.
Exactly, and also for folks where this is new, there's also already some videos out there on how the automation aspect of Dynatrace works. So one of the videos I can highly recommend is called Automation Without Boundaries, where we have Christopher, who was actually one of the key people behind the workflows, is walking through Dynatrace workflows and how they work and what you can do. But yeah, the forecasting, so this is an app that I would need to install, or is this automatically installed now by default?
You have to search this Davis task in the hub and install the app, and
I think I will do this right away, because I need this next week when I'm on site with some more Dynatrace users.
That's a good idea.
Yeah.
And you can find a lot of great analyzers in there, so it's always nice to look there.
Yeah, so that means the analyzer, that the drop down where it says generic forecast analysis. Oh, okay, wow.
There are many analyzers available, but not all of those are yet in production.
Yeah, I saw some debug things in there, but that's great. I mean, you are adding more and more capabilities, and that means people just from a time to time just check your hub. If you've installed this app once, check in the hub if there's new app versions available, right? It's like on your mobile app. You
Yeah.
also get notifications that there's a new version available. So the same will be true for all the Dynatrace apps. Perfect. Do me one more favor. Can you go back to the notebooks?
Sure.
Yeah. So folks, this is for me the magic moment now where we are in the Dynatrace kind of history, that we go from an APM solution to something much bigger. I mean, I think we've left the APM track a while ago because we've been doing much more than APM for many years now. But what we're doing here is like really analytics. I think we enable organizations to truly become data-driven organizations, and then also do automation, predictive automation, based on data, on any type of data. And this is why it's so important that we made the strategic decision to put all the data, the logs, the metrics, the traces, the events, into a common data store, which we call Grail. And we have a common query language, which we call DQL, Dynatrace Query Language, so that you can query any type of data with a simple, single language. You can then visualize it, you can analyze it, you can do predictions now, and then you can automate on top of this. Yeah. Wow. Linda, Bernhard, anything else? Or I guess that's a lot already. Or is there anything else?
No, I think that's it for today.
That's
So
perfect.
thanks for having us.
Yeah, and you said it right, for today, but there's more coming, I'm sure, in the future. So with this, I want to say thank you. And folks, if you're watching this, you either watch this on YouTube or on Dynatrace University. We will also upload the nice slides that Linda and Bernhard built on University, so that you also have the visuals. So if you're watching this on YouTube and you are a Dynatrace user, go to university.dynatrace.com. There you'll find the same video under Dynatrace webinars. And there's also a resource tab where you can then also download the slides. All right. Then I would say, Dankeschön. Bis zum nächsten Mal. See you next time.
Ciao.
Thanks. Ciao.
Bye.